We all have to go places by traveling distances, but not always is that speed going to be the same throughout the whole journey. And when that happens, we'll have to use math to figure out how long it's going to take. Let's get started with the formula for distance, speed, and time. Distance is speed times time. Speed is distance divided by time, and time is distance by speed. And when you're doing this, make sure your units are consistent. Like you're gonna have a speed in miles per hour, and then find your answer time in minutes without converting. The units, make sure you don't mess those up, because that can be a great pitfall. And then there's a formula for average speed. So average speed is total distance divided by total time. And a common mistake is to assume that average speed is the average of all the speeds. Now, this is only true if those speeds are being traveled at an equal amount of time. But sometimes what happens is that they say 1 mile, you're going 40 miles per hour, 40 miles per hour, and another mile, you're going 60 miles per hour. Then you cannot just average 40 plus 60 divided by 2 because the amount of time that each of those journeys take is different. Let's explore some average speed examples. Sohol is running along a 2-mile path at 8 miles per hour and back on the same path. On the way, he is tired, so for every 1 mile he runs on the way back after that mile, his speed instantly reduced by 1 mile per hour. What's the average speed throughout the entire trip? Okay, so on the way there, on the way forward, the speed is 8 miles per hour consistently throughout. And remember, average speed is total distance by total time. So let's find the total distance first. What's the total distance? Well, let's move out of the way first. Total distance divided by total time. The total distance, well, it's a 2-mile path, and Sohol goes there and back. 4 miles, right? Total time. Now, this is a tricky part of the problem. To find the total time, we can't just do it all in one step. We're going to have to take each interval and look at the amount of time it will take separately. Okay, so first of all, how long will the journey there take? The journey there, well, it's a 2-mile path moving at 8 miles per hour, so we just use the formula. The time is distance by speed. Distance is 2 miles, speed is 8 miles per hour. The time is 1/4 hours. And be careful, not 1/4 minutes, 1/4 hours, because it's miles per hour. Okay? 1/4 hour. So that's how long the journey there will take. Now, what about the journey back? Interesting. So it says here in the question, on the way back, for every 1 mile ran, the speed is instantly reduced by 1 mile per hour. So initially, the speed is going to be 8 miles per hour, but after 1 mile is run, so for this green part, the speed will still be 8 miles per hour because that was the speed from the beginning. But it says that after every mile ran, the speed is instantly reduced by 1 mile per hour. So after 1 mile is ran, now the speed is 7, right? And after a second mile ran, the speed is now 6, but there's nothing after that. So just 8 miles per hour for this 1 mile, and 7 miles per hour for this mile here. And now we just break it up into pieces. Again, you use the same formula. Time equals distance divided by speed. And I'm just going to write it in shorthand notation now. T equals distance divided by speed. The distance is 1 mile. The speed is 8 miles per hour. And I'm talking about the first part over here, this part. And maybe, you know what, it will be better if I make it the same color so it matches. Let's see, this color. Okay, so for this part of the journey, this part will take 1 mile divided by 8 miles per hour, 1/8 hours. So this part, 1/8 hours over here. Now what about for the red part? The red part over here, the time is distance by speed again, right? The distance is 1 mile, the speed 7 miles per hour, so 1/7 hours. Okay, so that means the total time is 1/8 hours plus 1/7 hours. And this is the total time for the entire journey. Now all that's left to do is evaluate this expression. Okay, so first of all, let's add fractions in the denominator. Interesting. So let's find a common denominator first of all. The common denominator is 56, right? For the bottom. So 14 over 56 plus 7 over 56 plus 8 over 56. That's 4 over 29 by 56, which is 224 over 29. Right? Because we just flip the fraction when we're dividing. So yeah, the average speed over the entire journey is just going to be equal to 224 over 29. So the key idea here in this problem was breaking it down into pieces, finding the total distance, and then finding the total time for each part of the journey and adding them up. And then we just evaluated. Let's try another interesting problem from the AMC 8. Each day for 4 days, Linda travels for 1 hour at a speed that resulted in her traveling 1 mile in an integer number of minutes. So, Linda for 4 days, so let's write day 1, day 2, day 3, and day 4. Each day, Linda travels for 1 hour, so 1 hour for each day. And it says in the problem that a speed that resulted in her traveling 1 mile in an integer number of minutes. So in 1 hour, let's continue reading the problem. Each day after the first, the speed decreased, so the number of minutes to travel 1 mile increased by 5 minutes. Okay, so let's say there's an X minute mile in day 1. On day 2, increased by 5, so X plus 5 min. And I'm just going to write min. And this is for 1 mile. 1 mile, how many minutes it takes, right? And this is be X plus 10 minutes and X plus 15 minutes. So it also says, remember that the speed that resulted in her traveling 1 mile in an integer number of minutes. So all of these are integers, which means X is an integer. So we know X is an integer, which is good. But then it also says that her distance traveled was also an integer number of miles. What does that mean? So if 1 mile takes this many minutes, then 1 mile has to take an integer number of minutes. Let's convert. 1 hour is the same thing as, of course, 60 minutes, right? So 60 min. 60 minutes. So this means that 60 minutes total divided by X, this must be an integer because, remember, this is the total time, this is the time for 1 mile, so this is the number of miles. Similarly, 60 over X plus 5 miles, let's write miles, 60 over X plus 10, and 60 over X plus 15. And this is the number of miles. But it says this must be an integer. Interesting. So that means X plus 5, X plus 10, and X plus 15. They all must be factors of 60 for this fraction to be an integer. Oh, but so X, these are all fractions. They must all be divisible by 60. So let's write out the factors of 60. 1, 60, 2, 30, 3, 20, 4, 15, 5, 12, 6, 10, and that's it, right? So we need to look for 4 factors such that we go up by 5 each time. So we need to look for factors that are differ by 5. So let's see, what factors here differ by 5? We have 1, 6, but then there's no 11, so that won't work. 2, there's nothing. 3, there's nothing. 4, nothing. 5, oh, for 5, we have 5. Let's do this with permanent. 5, 10, 15, 20. Aha! 5, 10, 15, 20. So 5, 10, 15, 20. They all differ by 5, just like these numbers, and they're all factors of 60, so that works. So that means that x equals 5, right? So what is the total number of miles for the 4 trips? To do this, all we have to do is plug it in. So x is 5, right? So 60 divided by 5, 60 divided by 5 plus 5, 10, 60 divided by 5 plus 10, 15, and 5 plus 60 divided by 5 plus 15, 20. And this is just equal to 12, 6, 4, 3. We add them up for the total miles for the 4 trips to get 25. So the total miles is 25, and that's our answer. Let's quickly review. So 60 minutes for each day, and each mile can be done in this many minutes because it says increase by 5 minutes over each day. And then we saw that the number of miles must also be an integer. So we found that they must all be factors of 60. We analyzed the factors of 60, found that 5, 10, 15, 20 works as 4 consecutive numbers that differ by 5 and are factors of 60. We plugged them in, added them up, 25. Okay, another cool AMC 8 problem. A bus takes 2 minutes to drive from one stop to the next, and waits 1 minute at each stop to let passengers board. Zia takes 5 minutes and walks from one bus stop to the next. As Zia reaches a bus stop, if the bus is at the previous stop or has already left the previous stop, then she will wait for the bus. Otherwise, she will start walking towards the next stop. Suppose the bus and Zia start at the same time towards the library, with the bus stops 3 behind. How many minutes? After how many minutes will Zia board the bus? Let's draw a little picture here. Let's call this stop 1, stop 2, stop 3, stop 4, 5, and let's just draw a few more just in case. Stop 6. And remember in the problem it says that Zia starts 3 ahead. So let's say the bus starts here at stop 1. Zia will be at stop 4 already. Okay, so let's just break it down here. After 0 minutes, let's make a nice little table here so we can organize our information. After 0 minutes, Zia, so basically the initial position, is at stop 4, and the bus is at stop 1. So the key thing here is Zia will stop whenever the bus is within basically one stop of Zia, right? Because it says here, if the bus is at the previous stop, as Zia reaches a bus stop, if the bus is at the previous stop or has already left, then she will wait. Otherwise, continue. So Zia for bus 1. That's the stop number after 0 minutes. Now, they said the problem says they both take off at the beginning. So after 2 minutes, what happens? After 2 minutes, remember it takes the bus only 2 minutes to drive from one stop to the next. So after 2 minutes, the bus will already be at stop 2, right? And Zia will still be somewhere between 4 and 5. Because Zia takes 5 minutes to go from stop 4 to 5, not just 2 minutes. So Zia will be somewhere here on the way to stop 5. Okay, now what about after 3 minutes? Remember it says here in the problem, the bus waits at 1 minute at each stop to let passengers board. So after 3 minutes, the bus will still be at stop 2, just about to leave for the next stop. And Zia will still be between 4 and 5 because 5 minutes have not passed yet. But this time maybe a little bit farther, maybe somewhere here. Now, what about after 5 minutes? So after 5 minutes, the bus will have left the second stop and reached the third stop. So bus will be now here, stop 3, right here. And Zia will have finally reached stop 5. It takes exactly 5 minutes for that to happen. Okay, now what's next? Now 6 minutes. So the bus has just arrived at stop 3. So now after 6 minutes, the bus will still be at stop 3 because of the wait time between stops. The bus will still be at stop 3, just about to leave for stop 4, the next stop. Right? So now let's just quickly summarize everything that's happened so far. So initially they started at 1 and 4. After 2 minutes, the bus reached stop 2. Then the bus waited for 1 minute, then reached stop 3 after 5 minutes. And Zia just completed one stop after 5 minutes. And after 6 minutes, the bus has finished waiting at stop 3 and is ready to move on. And Zia is somewhere between 5 and 6 now. Somewhere between 5 and 6. Okay, now what about after 8 minutes? After 8 minutes, the bus will have finished reaching stop 4. So now the bus will be at stop 4, right? Because it takes 2 minutes for the bus's journey. And Zia, well, it takes 5 minutes per stop. So Zia will still be between 5 and bus stops 5 and 6. Okay, so let's go back to the problem here. It says that Zia takes 5 minutes, and as Zia reaches a bus stop, or if the bus is at the previous stop or has already left, then she will wait for the bus. But as you can see, after 5 minutes, that did not happen because Zia was still 2 stops ahead. It was not at the previous stop yet. Will this happen after 10 minutes? After 10 minutes, will Zia be within a stop of the bus? So after 10 minutes, Zia will finish walking 2 stops, so to stop 6, right? Finally reach stop 6, and the bus, well, the bus will first of all, the bus, okay, let's take an intermediate first, right? So after 8 minutes, the bus reaches stop 4. So after 9 minutes, the bus will be done waiting, right? Because it waits 1 minute at stop 4 before taking off. So after 9 minutes, Zia will be almost there to stop 6, and the bus will have been done waiting at stop 4, and will be ready to move on to stop 5. And then after 10 minutes, like we were discussing earlier, Zia will have finally reached stop 6, and the bus will be halfway there between stops 4 and 5, right? The journey takes 2 minutes, 4.5. Now, is the bus at the previous stop or already left the previous stop from Zia? No. Because Zia is at stop 6, and the bus is more than a stop away at stop 4.5, in between stops 4 and 5. So Zia will not wait and continue the journey. So after 11 minutes, we're just taking this piece by piece here. After 11 minutes, the Zia will be somewhere between 6 and 7, right? 6 to 7. And the bus will have reached stop 5. After 12 minutes, the bus will be done waiting at stop 5 and ready to leave, and Zia will still be between stop 6 and 7. After 14 minutes, the bus will have reached stop 6, and Zia will have reached stop 6, right? But Zia will still be between stops 6 and 7, because in order to reach stop 7, it will take another 5 minutes after Zia reached stop 6 after 10 minutes. So 5 more minutes. So when it's 15 minutes, Zia will finally be at stop 7, right? Okay, so after 14 minutes, the bus After 11 minutes, it was at stop 5. Then after 12 minutes, we found out that because the bus was at stop 5 earlier, it's going to be ready to leave for the next stop. This should be 5 here. And then after for 2 more minutes, the bus will have finally reached stop 6. Okay, because remember, after stop 5 after 11 minutes, then 1 minute of waiting still at stop 5. Then after 2 more minutes, it goes to the next stop. And then after 15 minutes, Zia finally reaches stop 7, right? Because it takes 5 minutes per stop, so it starts at 3, 1, 2, or yeah, starts at stop 4. Sorry, start in 1, 2, 3, and the bus will be somewhere between 6 and 7. Now will Zia stop? Yes. Now Zia will stop and wait because the bus is at the previous stop or has already left. The bus is between 6 and 7, so Zia is here waiting, and the bus is somewhere between 6 and 7, so it has already left the previous stop, which is 6. So now Zia will wait. And how long will it take for the bus to finally reach the stop 7? Well, remember that over here it reached stop 6 after 14 minutes, and it will still be at stop 6 after 15 minutes because of the 1 minute wait time. So then after 17 minutes, the bus will have finally reached stop 7, right, 2 minutes after it leaves. And Zia will be there waiting at stop 7 and board the bus. So our answer, 17. So the key idea for this problem was to just take it piece by piece, and you didn't have to write all this table like I did. I just did it just to be clear and make it hopefully easier to understand. But the key idea is you just have to realize when the bus will be close to Zia. And then when the bus is indeed close to Zia, then you know Zia will stop. And then you just take it piece by piece until the bus is within 1 of Zia. Okay, next problem. Points A, B, and C lie in that order on a straight path, where the distance between A and C is 1800 meters. Okay, and it says that there's a point B in between here because A, B, and C lie in that order. Okay, so Ina runs 2 times as fast as Eve. So let's say Eve runs at a pace of x, then Ina will be the pace 2x. Paul runs twice as fast as Ina, so 4x. The 3 runners start running at the same time, with Ina starting at A and running towards C. So Ina, boom, like that. Paul starts at B, runs towards C, Paul. And Eve starts at C, running towards A. Like that. Okay, and when Paul... Okay, what does the problem say? When Paul meets Eve, he turns around and runs towards A. Interesting. So, Paul is running this way from B to C. Eve is running this way. Eventually, they're going to meet up at some point in the middle, right? But the question is, where will they meet up? Paul goes 4 times faster than Eve. So, if Eve is running 4 times slower than Paul, after some amount of time, they'll both converge at some point. Paul will have run this much distance, Eve will have run this much distance, right? But remember, Paul runs 4 times faster. So whatever this distance is, let's call it 4a, will be 4 times this distance. Because Paul runs 4 times faster than Eve, so we'll have covered 4 times the distance once they both converge at this point. Okay. So then, so let's call this distance over here 4a and a, and then this will be 1800 minus 5a from A to B. From A to B. Cool. So it says that once Paul reaches Eve's point and then goes back, meets Ina at B. So Paul runs 4A, and then Paul goes from here to here and then back. So 4A plus 4A back. That's 8A total. So Paul runs 8A distance, and Ina, by the time Ina reaches B, 1800 minus 5A distance. But remember, Paul is 2 times as fast as Ina, right? 4x, 2x. Paul is 2 times as fast as Ina, so this distance that Paul runs must be double the distance Ina ran. So we have now an equation, a simple one variable equation. 8A is double 1800 minus 5A, right? Paul's distance that is run before reaching B is double Ina's distance. And now we just solve. 8A equals 3600 minus 10A. 18A is 3600. A is 200. So then the number of meters from A to B is just 1800 minus 5 times 200. That's 800. So our answer is just 800. Okay, let's summarize really quickly everything that happened in this problem. First, we look at their speeds. So this was their speeds. Or we know Ina is 2 times faster than Eve, Paul 2 times faster than Ina, or equivalently 4 times faster than Eve. And then we found that for Paul and Ina to meet at this point here, this distance must be 4 times more than this distance. So 4A, A. And then we say, okay, the total distance is 1800 meters, so from A to B is 1800 minus 5A meters. And then we saw that Paul goes from B to here to back, and Ina just goes from A to B. So Paul's distance must be double of that. We found a simple one variable equation, solve to get our answer. Let's now explore another cool topic, sequences and series. Arithmetic, geometric, some interesting applications. Click right over there to see that video.